What's up, everybody? Based off our most recent LinkedIn poll today, I'm going to tell you about how machine learning forecasting actually works, and we're going to use the example of a lemonade stand. So we're going to be forecasting with a lemonade stand. So I'm excited. Hope you're excited. Let's dig in. Data is the catalyst for change. So first, I want to dispel some theories. Here's what I thought machine learning did, right? I thought you could, if you're forecasting lemonade stand sales, right? Or, for demand planning purposes, you want to know how many lemons you're going to buy, how much sugar you're going to buy, etc., right? I thought you put in your sales data, your purchase data, your forecast data, weather data, you put in how many, population of your town, uh, you know, events, things like that. And then the programming was just use this forecast. And that is not how it works. Okay. So this is one of the most important things to remember is that machine learning does not mean machine brain. Okay. Unlike humans are able to do what's called context switching, where you're able to listen to something like this video, and then you can get distracted and do something else for a second, right? We can switch really quickly what we're doing, right? And machines do not do that, right? They're focused, they're myopic. So this is not how machine learning works, much to my displeasure. So the way it works is, let me zoom in here. How it actually works with a lemonade stand. Okay, so you have three different data sets that we're going to consider. Okay, first is training. You need to train a model on what normal looks like, what's happened, right? So let's just pretend that, hey, this is our historical sales. We got the quantity of lemonade sold. And then we have our weather range. Now, if you notice, I put a range in there. I didn't put an actual, high or low. And that's because when you have infinite options like weather, right? Machines are more, it makes it difficult for them to translate it. Excuse me. So we use ranges, right? So we'll say we have location ABC, we have one item, right? And maybe we have other items. We have strawberry lemonade, raspberry lemonade, whatever. And we have 10 different locations. But we got a lemonade stand, right? What our location, we got our one SKU of lemonade. We have the date and how many we sold, okay? So what we do is we put it all in one table, right? We say, this is normal, right? We're training the model to say this is normal. Okay. And then what we do is we say, based off of that, I want you to make a prediction on quantity. Okay. And that's what's called the testing data set, right? So the testing data set looks at the trained data, and this is where the machine learning comes in, is it iterates multiple times possibilities. And what it does is it optimizes for that error rate, right? So the first thing it does is it runs through your test data. It says, I'm going to make a prediction, and then it gives you an actual, right? And because there's an actual, you can now say an error rate, right? So this is data that exists, right, that you have at your disposal, but but the machine doesn't learn from it, right? It's only learning from this other data. So say take 80% of your data and then test it on 20% of your data, okay? And so it optimizes for the error rate, and it's going to go through a few different iterations to say, hey, how close can I get? How can I tweak my parameters in order to get to a lower error rate? Now, some nuances here. There's lots of different error rates. You can use the average percent error. You could use the square root of the average percent error. You could use mean squared. So the mean you square it, and that's the error, right? So all that to say, there's lots of different potential error rates that you could utilize that works for you. Now, from your perspective, what you care about most is maximizing sales. Lemonades aren't that expensive, so you're not too worried about over purchasing sugar, right? Because that's all your purpose is for this one, is you're just forecasting your sugar purchase, which lasts a long time. Lemons are a little bit more fresh, and so you can be a little bit more stringent there. But all I care about is that I'm never under forecasting, right? Now let's say you are using this for lemons, and you say, hey, the thing that matters most is that we get as close to the actual as possible across all periods of time, right? I don't want a situation, you don't want a situation where one day you have super high accuracy, it's 100%, and another day you have 60% accuracy. You want a bunch of days that are accurate, right? That's important to you. And the model doesn't necessarily optimize for that, right? It doesn't know how to optimize for that. That's your business metric that you're optimizing for. But all it knows how to do is compare the prediction versus the actual and create an error rate, right? So this is your testing. You optimize for the error rate. Now, as part of this step, this is the magic of machine learning, and why you really need a data scientist to help you out with it. There's lots of parameter tweaking, and there's lots of things in here that I'm definitely not getting into today, that are difficult to know, right? And so what you need to do when you're building this, or when you're working with a company like Whip Data to build your models for you, we just need columns, right? Throw in as many columns as you want. It kind of goes to that original point where machine learning isn't just throwing a bunch of data and saying forecast it. But in this step of the process, adding columns that might be relevant, add them in, because you don't know what's relevant. And that's the whole purpose of using machine learning. Now, if you were confident, hey, weather's going to be 105, and I know that when it's super hot, I'm selling a bunch of lemonade, right? Then you don't really need machine learning, right? You just use a forecasting tool. So the machine learning tool is used when you have lots of different columns that you can utilize for demand planning or whatever else, right? Marketing campaigns and, last 12 months sales, right? You could lag features in here. So this is the second data set. We have our training and we have our testing. And then the last thing that matters is our production. Okay. Now this is, you do not know the actuals. So what we do is we say, this is our trained model. Once we've optimized that whole thing, we said, this is the model that I like to use, that I want to use. We save that, we snapshot it, we say, this is the model. Then in production, we say, reference that trained model. Okay, look at that trained model to run this. Now here is new data that you've never seen before. Here's the location, here's the item, here's the date, here's the weather and the forecast. And the weather, and then the model gives you the forecast in return. Okay, so to recap, we have our training data set, which is 80% of existing data. We have our testing data set, which is 20% of existing data. The training, you put everything in there, including your actual quantities. Testing, you don't put actuals in there. You just ask it to predict, and then it optimizes for an error. And then in your production, you say, hey, I have this many, this is the date I'm going to be selling on, and here's the weather forecast. And for our purposes on this lemonade stand, that's all we're doing is, what the impact does the weather have on our forecast, right? This is the forecast quantity, and it's going to do its best to optimize. Now, you could look at this forecast and say, I'm going to buy enough lemons for 100, right? You could look at this and say, oh, well, if the forecast is saying 106, I know that it kind of tends to skew down, and I know my error rate, it's always kind of a little bit lower than I'd like, right? So I'm gonna buy enough for 120, right? In hopes that, hey, maybe we get a little bit more, right? So captures I hope this really captures the sense of the data process of machine learning, specifically that it's not a brain. You have one table, you predict one column, and the machine is just putting weights on each of the other columns. Right now, there's lots of different things you can do after the fact. You can use this and you can compare it to a human forecast, right? And this is something I recommend a lot. Is you have your machine learning forecast, but don't just use it as truth, from day one, right? You don't have to, right? You have your machine and you have your human, and you just compare the two. And then when there's differences, just look at why, and then add that column in your database. You run the training data set, see how close you get to your errors, and then keep comparing. Now, you still have to make a decision of how many lemons you're going to buy, how much ice you're going to buy, how much sugar you're going to buy. It's fine, you know. But you just keep getting better and better over time. A machine learning algorithm and a forecasting tool is not going to solve your problems. You have to make decisions and learn over time and grow. And it's not that you'll eventually get perfect, it's that humans are changing. So this is a constantly evolving process where you're constantly trying to improve your prediction and improve how humans are interacting with your product or whatever, right? So hope you enjoyed that, and I'll see you next time. Bye.